Hi, so my name is Gabriella Pinter. I'm originally from Hungary, but I've been living in the US for many, many years. And I'm at the University of Wisconsin-Milwaukee. What you see behind me is Lake Michigan, which is really, really beautiful and always changing. Um, I, I work with kids quite a bit. I originally studied to become a high school teacher and then became a mathematician, but I enjoy working with kids a lot. I've been running math circles for a long time at the university. And when everything shut down in 2020, after a while, I found my way to some online communities that worked with math circles. And I am in those communities ever since. One of them is the Julia Robinson Math Circle that really put all their activities online when COVID hit. And today I decided to do one of those activities, which I really enjoy, and I think it works at many, many different levels. So let me share my screen here. Can you see my screen?
Yes.
Yes, okay. So this is the main page for the Julia Robinson Math Festival. They are running in-person events nowadays, also online events. In particular, we have a Julia Robinson Community Math Circle, which is once a month on a Saturday afternoon. And we have kids, we have a lot of adults too who participate. We have an adult room. So if you'd like to check it out, how it looks like, or you are thinking of running a math circle at some point, but would like to have more experience, this is a place where you can just observe and learn and see how kids are interacting or adults can interact with different kinds of puzzles. So the puzzles are very, very nicely done at this point. And what I'd like to introduce today is cup stacking. I'm going to put the link for this in the chat too. So you can open it up as well. So with all of these activities, typically there is a very short description on how they work. There is a festival guide. So they can be done, and originally they were designed to be done in person. So these are perfect for the classroom. And in the festival guide, it describes exactly what kinds of materials you use. It gives all the PDFs that can be printed out to make it really nice in a classroom, or if you are thinking of a math circle or a festival too. But they work online as well. So if you happen to work with students online, or if you ever need to do this again, totally online, then it's also a good option. So here, let me introduce the activity and go through this tutorial. So our goal is that we would like to have all these cups in one tower. So we want a single stack. Now, how can the cups move? Well, we can choose a cup, and then since it's just a single cup, it can move one step. Since this is 2, right, it can move one step to the left or one step to the right. And here it's very clear with the arrows that it could go either on 1 or 3. The tutorial wants us to click on 1. So now we see a stack of 2 cups. Once we have a stack of 2 cups, this 2 cups will have to move 2 steps, right? And well, it cannot move 2 steps to the left because there are no positions to the left of 1 in this case. So the only place where it can move at this point is 3. Now, if we make a move that we would like to undo, we can click the undo button. So this really is the tutorial that describes how to work with the activity. So we don't have to move this this stack of 2. We can move the cup from 3 to 4. And then it tells us here in the right that it's going to keep track of the towers that we built. So here you can look back to what kinds of towers you were able to build. There are all kinds of extra things. We can increase the number of cups. We'll be able to change the problem a little bit through the gear. So we can actually go two-dimensional also. So there are lots of extra possibilities here, but let's try to play. So let's try to do the actual fun here. So our goal is to build one tower, right? So have all these cups in the same stack. So anybody would like to make a first move? Or are there any questions on how this goes?
Oh, I have a movement, maybe from 5 to 4.
Okay, so click on 5 to 4. Great. How would you continue?
And then 4 to 2.
To 2, right? So at 4, we have 2 cups. That has to move 2 steps.
And then the 1 and 3 can move on to the 2.
So 1 can move here, 3 can move up, and that says, hooray, we did it, right? So we built a stack on position number 2. And if we look in here in the records, it says, okay, you were able to build it. And you can even retrace your steps. So this is really done very nicely. It tells us exactly how we did it. So what to do with this? What maybe do one more example here before we start playing some more. We were successful building the stack on position 2. Could you build it somewhere else? So maybe let's try another set of steps with the goal of building it somewhere else.
5 to 4.
Okay.
And then 3 to 4. There you go. And then 2 to 1. And then 4 to 1.
And then 4, right? Great. So now we were able to build it on position number 1. And again, you would see that in the records too. So now we were able to build it on 1 and 2. Do you think we can build it at any other place?
Two to 3.
Okay, so go 2 to 3.
And then 3 to 1.
To 1.
And then 5 to 4.
5 to 4.
And then 1 to 4.
1 to 4. Wonderful, right? So now we are on 4. So 1, 2, 4, 5, we were able to build it. Nice. Can we do a different one?
How about 4 to 5, 3 to 2, and 1 to 2, and then 2 to 5.
And then 2 to 5, right? Very nice. Okay, so this is curious, right? We built it on 1, 2, 4, and 5, and you would see it exactly here in the records. But we did not build it in the middle. Can we build it in the middle? So maybe this is a good point. Is everybody able to bring up the activity on your own screen? So I think
yes,
it's,
I think
yes?
so.
Okay, so I think it would be great to maybe go into breakout rooms a little bit because I just came back.
We'll be back in 23 seconds. It was a look at 5 of them. Now there are, I think, 6 rooms, and 4 of them had screen shares and were going. One was doing it independently.
Okay. Wait, so you are saying the rooms, oh, okay, everything closed, right?
Yeah, people should all be back now.
All right. So I hope you had some time playing with this app and examining some of the things that it can do. So what kinds of observations did you make, or what happened in the breakout room? Who would like to share?
Hi, this is Belinda.
Hi, please go ahead.
I did try a couple of them, but we didn't have a screen on to move the cuts, but I did colored pencils.
Mhm.
I came up with just 2 times that it came into, I could stack them in 2 different stacks. I mean, like say the first time I stacked it, it stacked up in the second position.
Mhm.
Then when I tried it the second time, I stacked them in the 4th. But it depends how you move it. But that's all I observed. I don't remember the steps I took, but I know I did it.
Mhm. So second and third positions?
Yeah,
Great.
and 4th.
Mhm.
That's all I did.
Very good. Any other things people tried in the different breakout rooms?
Gabriella, this is Virgilin. When I tried it the first time, I did get some that were stackable. And then I tried it one time, I ended up with saying, oh no, there are no other possible moves. So there is a possibility of it not working. And I was like, how come it's not working? It just wouldn't find any more stackable moves. So I found that interesting. And I thought that with little kids, like the younger elementary, this would be very interesting because it'll help them to identify patterns. It'll help them to recognize numbers and colors. So I thought that was interesting. And then I figured that when it said, oh no, there's no other possible moves, it shows that sometimes you can get it wrong. And that's important too at a younger age, that you're not always going to get it right.
Yes, definitely. So maybe it would be useful to show such a configuration when it doesn't go right. What would be one way to do this, right? For example, if these two cups, maybe that's not what we want.
It seemed like when we tried it, it was always the single cup that completed it. And I tried looking for a pattern where, like, if it were 3 to go to 3 or 4, but I couldn't find it. We just didn't get that far.
So you mean smaller number of cups?
So like when we had a stack of 3, it was always a single cup that just jumped 1. And that's how we won.
Like,
And you see how the 3 goes to 5.
mhm.
And then that 4, that single cup is always what wins it. It's always a single cup, it seems.
Oh, I see. Mhm. So that it moves there and then there is a single cup. Could we do those steps in a different order too?
Yeah, you could take your 5, move to a 4, and then both of them on top. Then you'd get your double cup on a triple.
Right. So we could do this too. Nice. Mhm. So can we create an impossible situation here when we cannot go on? What if we try?
So let me say we are getting some wonderful questions in the chat. I want to put these sort of up. If I was in the classroom, I'd write them on pieces of paper and hang them like sports banners around, and then later try to figure out partial guesses and then answers. So Imelda wrote, she's wondering if there's such a thing as the least number of moves to stack the cups. Wonderful question. Questions are beautiful things. It would take some while to answer, first making some conjectures. Clorinda was asking, how many different ways can you stack them in one place? Is there a pattern? In the first space, how many different paths can you do to stack them? So, you know.
How many different? So let me try to record the questions here for everyone.
Yeah, we can. How many different paths can you do to stack the cups? Is one question.
Mhm. At the different positions, right?
So how many ways can you stack them in one position? And so if you're putting them in one position, how many different ways can you do that? Both of those questions are due to Clorinda. If you want to label that as Clorinda questions.
Clorinda, C-A-R, sorry. I can see the chat.
L-A-R, Clorinda, Clorinda. I think it's C-A-L-E-R-N-D-A. G, yeah, C-A-L-A-R-E-N-D-A. Right, it's and C-A-L-A-R-E-N-D-A.
Okay, just yes.
Yeah.
Yes.
And so how many different ways can you stack the cups? How many ways can you get them to the same location?
Mm-hmm.
I'm paraphrasing a little. Imelda, what's the smallest number of moves to stack the cups? Right? How many is a natural math question, right? 1, 2, 3, and it can be interesting at all ages, right? And so these explorations, right? Now that you're starting to ask your own questions, you're taking the activity further, and it can keep going. You can keep this going all semester.
Yes.
You're here, rah, yay.
Any other nice questions we'll have?
I have one. How many possible combinations can we get from stacking into one place?
So is that Ty asking how many or who? Name it.
How many possible combinations of numbers can we get in one position?
That's fundamental counting principle. That's nice.
Question 3 was Imelda, by the way.
Sorry. I will try to look through the chat and attribute the questions correctly. I was asking. Question 3, you said?
Was Imelda. Yeah, I just laugh.
Okay. Right.
Brian just added relationship between number of cups and numbers of ways of stacking them. What a nice function, right? And yeah, come up with examples of functions that do interesting things. Here's a function, number of cups, number of ways to stack them. It's not just f of x equals x squared. Doing function notation is, maybe middle and high school students, but you could introduce this just with small numbers to kids to get them ready earlier. So that was Brian.
Brian?
Brian with a B.
Oh, sorry.
B-R-I-A-N.
Great. Any other ideas? And definitely this activity works really well in a classroom with cups. So kids enjoy manipulating them a lot. So it's definitely a very hands-on, nice activity. And they can generate all these questions too. So it's fun to then kind of going and trying to answer them. So is it possible to stack the cups according to the number of steps jumps at each space? What do you mean? That's an interesting question. Maybe I can just copy it here. So, do you mean? Is it possible to stack the cups only to the right? Okay, sorry, I lost my screen. Odd number of cups versus even number of cups. Beautiful questions, great. Is it possible to stack the cups only to the right or to the left? So with 5, we were able to stack them to the left on 1, right? To the right on 5. Can we stack them in the middle? Has anybody succeeded stacking them in the middle?
Yeah.
How would you do that? Maybe start from the beginning, right?
Actually, maybe go from 4 to 5, and then 5 to 3, and then 2 to 1, and 1 to 3.
2 to 1 and 1 to 3. And if you look at this step by step, one more time, we ended up in the middle. How? 4 went to 5, and really 2 went to 1. And then both of those sides could jump onto the middle in some order. So with 5, we were able to stack the cups everywhere on each of the possible positions. 1, 2, 3, 4, 5. Do you think that always happens? No? So maybe you can look at these questions again a little bit, and I didn't have time to, I think I will need to copy the last few ones too, but try thinking about one of them or more of them and experiment a little bit more. So choose your favorite question here. And maybe we can go to breakout rooms again. So are there any interesting observations you'd like to share? What did you work on? What did you find?
Got brave and tried the 2-dimensional.
The
One
two-dimensional.
solution.
Nice.
If you have 3 stacks in the middle, it can't go either way.
So yes, maybe I can go there. Let me navigate there real quick. So you were playing with this one, right? The two-dimensional version. So definitely if you run out of questions for the 1D, 2D is really interesting. And in this case, the rules, right, are at the beginning it's clear, right? One cup goes and now it's 2. And when you click on that 2, you see something interesting, right? It highlights the places where that stack of 2 can go. And at this point, it can go 2 steps to the left. But it turns out you can also go, which first seems, okay, we are going diagonal. So why can we go to this diagonally below square with that stack of 2 cups? So somehow that's a distance 2 from where the stack of 2 sits now. And the way distance is counted here is that you add up the number of steps you need to go horizontally and the number of steps you would need to go vertically, right? So to arrive at that diagonal square, we would need to go 1 step horizontal, 1 step vertical. 1 + 1 is 2, so that stack of 2 cups can actually go to B1. But now if you click on this 3, there's no place where it can go, because there are no places that are distance 3 away from this, where distance is again calculated by, this is the so-called taxi cab distance, that you add up how many steps you need to go vertically and how many steps to go horizontally. Okay, so yes, this is just one group started playing with the 2D. So I wanted to show that definitely you can go into that. But what other groups worked on, or what did you find? Anything you'd like to share?
We just worked on size 6, trying to get into all the places for size 6.
So do you think it's possible to put it, stack the cups at every position in size 6?
I think so. We didn't make it all the way, but I think so.
Yes. I believe so.
Okay, so maybe let's explore this together a little bit. So our question is it possible to stack the cups at any position? And it's a very, very good problem-solving strategy to start small, right? So if you look at this question, let's start with the minimum number of cups here. And of course, we could start with 1, and then the question is real easy. But we can also start with 2. Can we stack them on position 1? Clearly, right? We can do that. But if we undo it, we can definitely stack them on 2. So either place, we can do it. Now, if we increase the number of cups, can we stack them at every position in this case?
Yes.
So how could it work?
2 to 3 and 3 to 1.
3 to 1, right? And if you can do this, if you can stack the cups on position 1, does that tell you immediately where else you can stack the cups for sure?
On 3.
On 3, right? Why do you say that?
You just reverse what? So instead of going from 2 to 3, you go from 2 to 1.
Go from 2 to 1, and then do that, okay? So in a way, we are doing the mirror steps here. And really what we could say is that by symmetry, we can do this. If you can stack the cups on 1, you for sure will be able to stack the cups on 3 by just mirroring your steps. So that leaves us with 3. Can we stack the cups? Oh, sorry, 2, yes?
Yeah.
Can we stack the cups on 2?
Yes. 1, 2.
And then 3 goes on top, right? So we can definitely do that too. So 3 works. So you go the next step up. Can we do this one on every place? And maybe we can start thinking a little bit strategically here too. If we want to stack them on 1, okay? is there a thing that we could do with all the other cups? So then in our last step, everything kind of jumps on that red cup on position 1.
You can have 4-3, 4-3,
and then 4-3 on to the 1-2.
So 2-1, 4-3, and then this goes on top, right?
So that makes possible.
That makes it possible. What else does this
Because
make
I
possible?
did the other way around that he actually do. So I did 4-3 and then 2-1. So that means there's 2 ways that you could actually do that.
Right. This can get, as you are starting to explore this a little bit more, it does get into that question that I think many of you really liked, how many ways we can build on the different positions, which actually is a very difficult question in general.
And that's going to be a generalization to the kids also with mathematics, that they can actually find many ways to solve a problem, and it might be different from others, but they would arrive with the same answer.
Yes, and that's very good that we can stack the cups in, let's say, on position 1 in many different ways, and try to see really how many different ways, and see that everyone can be successful, right? Stacking one way, finding another one, and then getting everything together. So if you think of getting the tower at 1, right? We were able to do it now several ways. What if we try to collect all the cups somewhere else? So what if we try to do something like this? So my goal is to collect the cups on position 1. And I use all the other cups, which is 3 of them. So I would like to collect them 3 steps away. So now this 3 stack could just jump on 1. Now, why this might be interesting, suppose you have 6 cups. And we would like to collect all of them on position 1. What could one strategy be to do this?
Try to get all the cups on position 6.
Right? So we have 5 other cups. We could try to get them on position 6, which if you just for a second forget about that cup on position 1, we reduced it to a smaller problem. We have the 5 cups now, and we want to collect all of them on one side. Can we do that?
Yes.
Remember, 5 cups, we were able to do collect them everywhere. So we can definitely do that.
Yes.
Like it's 2-3.
And do that.
Yeah. Then click that. Go to. Yeah, it could go 5. No. There. 5 to 6.
Right
6.
there. So we collected. And now they can jump to 1.
Okay.
So what did we use here? The fact that we were able to collect 5 cups at any position was very useful because we collected those 5 cups that originally sat at positions 2 to 6 on 6, and then that last jump was just on 1, and we have the cups collected on position 1. So this is good. We can do position 1, we can do by symmetry position 6. But is this useful for any of the middle positions? So think of the following. If I would like to collect all the cups here on 3, could we use this same idea? To the left, we have 2 cups. To the right, we have 3 cups. Where would you like to collect these 2 cups? So then both of them together can jump on 3.
We could go 2 to 1 to jump on 3.
Mm-hmm. And I can actually, right? So where would
Yep.
the
5.
So go 4 on 5 on 6, and then that could go back on.
on 6, right? We would like to collect them on 6 because that's 3 cups and that's 3 away from position 3.
I was going to go 4 to 5 to 6, but yeah, 5 to 4, then 2 jump over, then 6, 3 over.
Oh, wait. So if 4 goes to 5, you have 2 cups on 5.
That won't work
That won't go to
because
6.
you have 2.
Then you'd have to go to 6, and then you would go 3 spaces over that. You're correct.
So then it's 2, right?
Yep.
Okay. But you agree that we could try to use this strategy. We have the 2 cups here, the 3 cups here, and collect them on those 2 sides. And then they can all jump onto 3. So let's see how this works if I stop the annotation, right? 2 to 1. Now this stack goes on 3. 5 goes to 4. This jumps on 6, which is exactly 3 away from our desired position. And we are good. So by doing this, we solve this problem by dividing it into 2 smaller problems. We wanted to stack them on number 3. That involved a stack of 2 on 1 and a stack of 3 on 6, and then they can just jump right there, and we are good. So would such an idea work with every one of these positions? With 6. So if we wanted to collect everything on 2, what would this dividing into 2 strategy tell you to do? Can we take all these 4 cups? Where would you like to collect them? Which position? So we would like to stack everything on position 2, all 6 cups. This position 2, again, kind of divides all the cups into these 2 groups. We have a group of 1 and a group of 4 cups here. The 1 is no problem, right? It can jump directly onto 2, so that's fine. But now we want these 4 cups to also jump to 2. Can we collect these 4 cups into one tower so then they will jump directly onto 2? Which position would we like to collect them on?
3 would go to 4.
Okay. So 3 could go to 4.
And 4 would go to 6.
1 would go to 6.
And 5 to 6.
And 5 to 6,
And
right?
6 to 2.
And now this whole tower of 4 can jump on 2. And this can jump anytime, either before or after as well. So again, the problem, we divided it into 2 smaller problems, which before we solved already. And now we can see that we can use it to solve a larger problem. And in fact, in this way, you can prove that no matter how large number of cups you think about, so let's say how far this goes, we have many, many cups, like 11 here. Can we stack them on any position that we desire? Well, maybe if we choose position 1, okay, we could say, well, if these 10 cups that are to the right of 1 can be stacked on position 11, then that whole tower can just jump onto 1. So now it's a smaller problem. Can we put 10 cups onto one side? And then maybe we can explore that. 10 cups, we want to put them on one side. Well, that just says, well, can you do it with 9 cups? And then can we do 9 cups on one side? Well, that just reduces to 8 cups on one side. And you can go down in this way till the nice small cases that we already did. And you can convince yourself that, yes, we can stack all the cups, all the 11 cups on position 1. And basically it works the same way on any number of cups. You just have to be able to do it on every smaller number of them. So you can build up the argument from the smaller cases to the very general ones. So I think there were some other questions too that were really interesting to explore. So let me, I know we don't have too much time, so let me say just a few words about them. The number of moves is a really nice question because it's very natural. It comes up like, okay, how many moves will we need to make? And if you count the moves and you look in the records, maybe that doesn't show it very well, but if you really play it out, you will see that it's always the same number of moves. And you can think about why is that so? So what happens with every single move?
I think one of the interesting things is I tried it with the 10 cups. And if we do, for example, the 10 cups and we start with 4 to 5.
Okay.
And then, well, actually, no, it's 5 to 6. Move the 5 to 6.
Okay.
And then the 6 to 4. The 4 to 7. 7 to 3, and you go back and forth, you finally get to the end piece. That's
That's,
interesting, see, too.
that's a beautiful strategy. Exactly. Mhm. Very nice. Great. So that gets you to this. And I think students will discover this too. That's great. Yes. Mhm. So I know many of you were interested in the how many ways we can stack the cups at the different positions, or simply how many ways we can stack a certain number of cups, and probe this idea of what's the relationship between the number of cups and how many ways we can stack them. It's a very interesting question for which there is no simple answer. The small cases you can work out by hand. So again, we would start small, and if we have 2 cups, we can do really 2 things, right? We either have a 1, 2 if we are listing the numbers from bottom up, or we have a 2, 1. So there are 2 ways 2 cups can be done. If we look at 3, we could do it systematically. How many ways can we stack the cups on 1? How many ways on 2? How many ways on 3, which is the same as the number of ways on 1. So symmetry helps there. And again, count these up. What we are going to see is 4 ways. So we can do 4 ways. You can explore how that comes about. Then look at 4. The number you would find is 10. So it starts kind of like 1, 2, 4, 10. And then it grows kind of fast. So after that, for 5, we'll have 32. For 6, we have 78. There isn't a very clear relationship here. And one last comment, I know I'm out of time, is that when mathematicians or when people see these kinds of curious sequences consisting of integers, you look at the online encyclopedia of integers, whether such a sequence is represented there. And this sequence, this beginning part of the sequence is not in the online encyclopedia of integers. So people would get very enthusiastic about that and really try to figure this out. But as far as I know, this is an open question. So it's a wonderful, this activity, I think, is a really nice example where really very small kids can start playing with it. They can get a lot out of it just by simply recognizing symmetry, recognizing different solutions. What you said, recognizing that sometimes we cannot complete a solution. There are all of these great connections that can be explored, but then in the end, it can also lead to questions that nobody knows the answer to. And I really like those types of questions. And that was one reason why I wanted to present this one today. So thank you very much for participating and working with me. It was really wonderful. And I hope you like these activities and try out some other Julia Robinson ones too. Thank you.